Hello everyone, welcome to Practical Emission. This is Prajwal, and today we are going to discuss about some interesting and key questions related to electrical and electronics. Now, before getting it, let's get started. Okay, now as you can see the question. So our first question is like this: explain why materials like copper are good conductors in terms of free electrons. Okay, now let's understand. So, in copper, the free electrons are free to move. There is no bind limitations. Therefore, they are good conductors. Now, you understand in a sufficient way. So, in a metal lattice, I mean, our conductor is a type of metal. Okay, so we use a word that is metal lattice. Okay, so in a metal lattice, the positively charged ion, okay, are arranged in a fixed position while the free electrons around them move around. I mean, let's understand like this. This is our positively charged ion, or this is our electrically negatively charged ion. And this negative charged ion move around positively charged ion. Okay, so this sea of electrons allows metals to conduct electricity efficiently. The free electrons act as charge carriers, enabling the flow of electric current through the metal. Okay, this is what we are saying. Now you have confusion in metal lattice. Okay, so what the word mean? What is the lattice word mean? So it means like, so you have many charge carriers. Correct. Okay. Uh, Position in and out, and they have vibration or vibrating. You can. That's the meaning of this word lattice. So metal. Okay. And now let's see our second question. Our first question is this. Let's understand second question. Derive the expression for current density in a conductor using detail. Okay. So second question. Current density, here it is. The current density. We show this as capital A. Okay. Then in a conductor can be derived using Vd. And what the Vd means? This is drift velocity. Drift velocity is Vd. Okay. And our expression is J equals to Ne dt. This is our expression. Now let's understand one by one. So first let's see drift velocity, that is Vd. Okay. So our drift velocity is the average velocity. We can call it average velocity of what? And now what is average velocity? So there is a wire, I mean conductor, okay, and there is electric field. So what does it say? That under the influence of electric field, the average velocity of a charge carrier moving from one place to another place is called drift velocity. So there is a charge carrier moving from this place to this place. So they have some velocity, other velocity called average velocity, and average velocity called drift velocity. That is the meaning. Okay. Then there is E. And what does it say? So charge of the carrier. This is called charge of the carrier. So the charge of each carrier for electrons, it is the elementary charge. it is called elementary charge. Okay, then हमारा बच रहा है n. What is n? So n is number of density. This is number of density. And what is this? So the number of density is the number of charge carriers per unit volume. I mean the number of charge carriers uh, per unit volume. This is what it is. Okay. Then now understand this expression is named J equals to NEDT. Okay. So this means that the current density J is defined as the amount of electric current flowing per unit area of the conductor. Okay. And now let's see the third question. And our third question is name the five conductor and five insulator materials. Okay. So this is our conductor. Five conductor name, that is silver, aluminum, um, magnesium, then copper, then calcium, then zinc. This is our conductor, five conductor materials. And if we talk five insulator materials, and they were like glass, porcelain, porcelain, which is also we can say serum, okay, rubber, and mica, and we can say plastic, and in plastic we can add PVC, Teflon, etc. etc. So there are so many examples of insulator and conductor. Okay, and now let's understand our fourth question. That why don't insulator conduct? Why don't insulator conduct electricity even when voltage is applied? This is very interesting question. So अपना ये third हो गया था. Now let's see fourth question. So there are three reasons that insulator haven't electricity when voltage applied. What is the reason? First reason is electrons structure. Second reason is band gap, which is energy band. And our third reason is lack of free electron. Lack of free electrons. Okay. Now let's understand one by one. Our first reason is electron structure. And what does this mean? It means that atoms with electrons tightly bound in their orbitals. These electrons don't move freely. Uh, they require a significant amount of energy to break free and move. I mean, we can say this is one level of this is the path of the electrons. We could say. Okay. So our electrons are here. So for conducting electricity, it needs to be go there, then here, then here, then here. And when all electrons are here, then it is free. So from this place to this place, it requires a lot of energy. Okay, but in insulator, there is not a sufficient energy that push electrons from this place to this place, so that our electrons should have. Okay, that is the first reason. Second one is band gap. Okay, and what does this mean? So a large gap between the valence band and conduction to be the conduct electricity. What does this mean? Suppose that there is a valence band. and there is a conduction. Understand it. So valence band means where electrons are here, and valence band means our electrons have to be here, but here it is not. So there is a lot of gap between them. So from here to here, it requires more energy. Okay, that is the reason. Then our third reason is lack of free electrons. This one, I mean, a material with very few free electrons that can move around to carry current, high resistivity, a material with a high resistance blocking the flow of electrons. Okay, so these are the reasons behind of this question's answer, that why insulator doesn't conduct electricity. Okay, so we have completed our four questions, and in our upcoming videos we will discuss more creative, advanced level and tricky questions, so that you could understand electrical concept or electronic concept in a deep way. And for today, thank you for watching.